Hi, my name is Sean Sherry. Today I'm going to be going over a basic fluid mechanics problem. Today's question asks us to find the minimum tensile strength for a pipe used, and the requirements are 1-inch nominal pipe size using Schedule 80 common pipe sizes, which is a graph over here on the right, which we're going to be using, on a safety factor of 6. And the typical system pressure is going to be about 3 ksi or 3000 psi. So first, let's look at this chart over here. And we have the pipe inside diameter over here on the right. And then we have the nominal size in the schedule. So we're going to be using Schedule 80, so we'll be using this column. And the nominal pipe size is here, so we'll just find intersection. And it looks like our ID is going to be 0.957. So organizing this information, you have the ID 0.957 inches. And then your OD, that's just going to be 1.315. Again, in inches. And just to make things easier later on, our thickness is going to be OD minus ID all over 2. Just neaten this up real quick. Okay, and also we'll need our radius. Our internal radius, that is, which would be ID divided by 2. Okay, so the first thing we need to do is, we're on our way to making a solution here. We should probably find out if this is a thick or thin-walled pipe, which is the first step in finding the appropriate formula to use. So basically, what that formula for that is the ID. So test, it's going to be ID divided by the thickness. That equals about 5, and that the limiting factor, the determining factor here would be if it's less than 10, then it is a thick wall. So we'll use that formula. The formula given is the burst pressure typically equals the thickness times the tensile strength over 0.6 multiplied by the thickness plus the radius. However, we can reorganize this to solve for our problem question, which is asking for the minimum tensile strength. So let's do that. So basically I can just write this in MathCAD. Really easy to use. Tensile strength, that's going to be equal to, oh, I forgot to write the pressure in here. Pressure, it's going to be 3 ksi. So, tensile strength is going to equal pressure, and it's going to be multiplied by our denominator, which is 0.6, multiplied by the thickness, plus our radius. And we've got to capitalize the T here. And then I can go over and divide this entire thing by just the thickness. And lo and behold, that gives an answer in pressure, but it's in pascals, needed in let's see, could probably use KSI. I like KSI better. Alright, so 9.82 KSI. Now, we do have a factor safety of 6, which is very important because a lot of times these are used in hazardous conditions, so you want them to be super strong. So 6. So here, if you want to factor this in, now you could actually use the actual formula, which would be the working pressure equals the bursting pressure over your factor of safety. Or more easily here, I'm just going to insert into our formula, multiply the answer by 6. So we're looking at a material whose tensile strength is in the range of 58.917 KSI, or 58,000 PSI. I don't have a material data sheet in front of me, however, do have one potential material. It would be 4130 cold drawn steel, which has a rated tensile strength of 74,000 psi. Something like this would most likely fit our application. However, since it's not asking for a specific material, it's okay to just leave it in this formula right here at 59 basically KSI. And I'll just highlight this real quick for you guys. Okay. Well, my name is Sean Sherry, and thank you for taking the time to watch this video.